Hello everybody, welcome to an interesting video on an important topic from class 10, and this chapter is triangles, as you can see on the board, and this happens to be one of the chapters that students find to be a little tricky and hard, but let's try to simplify it as much as possible. And in this video I will be talking to you about summarizing basic proportionality theorem, and in the other videos to follow we'll be doing problems on basic proportionality theorem followed by similarity. Right? So without any delay, let's begin with the chapter and try and understand how this works. Now, before we actually go into the proof of basic proportionality theorem, the first thing you need to understand is what basic proportionality theorem is all about. Now, the best way to understand it is by taking a simple triangle. Let's take ABC to be our triangle. And your job here is to just find 2 points. Let's find a point D on AB. Let's find a point E on AC, and let us just join it. However, when you join it, make sure that this line is parallel to the base. That's the only condition you need to have. Alright? And there is absolutely no rule that D has to be the midpoint of AB and all that. No. D and E can be any random point. But as long as when you join DE, if it becomes parallel to the base of the triangle, your job is done. Once you do this, then according to BPT, if you measure the top part of it, and if you measure the bottom part of it, which is AD, and divided by the length of the bottom part, it automatically becomes equal to, follow the same pattern. Since you measured the top part here, measure the top part here, which becomes AE. Since you measure the bottom part here, measure the bottom part here, which becomes EC. This is called as basic proportionality theorem. The statement goes this way: in a triangle, if a line is drawn parallel to the base of the triangle from any two sides, then the two sides get divided in the same ratio, which means this by this becomes equal to this by this. This is the basic formula you have for BPT or basic proportionality theorem, but you can always extend it and make it a corollary, and I'll tell you how corollary looks like. Follow patterns. It's all about following patterns. There's nothing else. If you take AD, I'm going to write that, and instead of taking DB, I decide to take the entire side AB. Follow the same pattern on the other side. I took AD, which was a part of the triangle above, so I'll take AE this side, and since I took AB here, I'll have to take AC here. Can you modify it further? Why not? Go ahead. Now what I shall do is I shall take maybe AB first and divide it by DB. Follow the same pattern on the right hand side. I've taken AB here, I should take AC on this side. I've taken DB here, I have to take EC on this side. This is also corollary. So just identify the pattern in which you have taken your sides and your job is done. Alright, having said this, let us try to take one example on how basic proportionality theorem, which is also referred to as Thales theorem, works. For this, what I'm going to do is I'm going to take a triangle, call it ABC. As usual, take 2 points DE such that it's parallel to the base. Let's assume this is 4 centimeter, and let's assume this is 10 centimeter. And someone tells me this is 6 centimeter, and they want us to find out this side. Apply basic proportionality theorem, or you apply corollary, anything is really okay. So what I'm going to do is, since I just want a part of the side, I feel it's easier for me to just directly apply BPT. So I'm going to say, in triangle, these are the steps you will have to follow. As DE is parallel to BC, by basic proportionality theorem, AD divided by DB becomes equal to AE divided by EC. Alright, now let's substitute the values that are given. AD is 4 centimeter. I'm not going to write the unit when I substitute. It's anyway ratio. DB is how much? 10. What's AE? 6. What's EC? Unknown side X. Now just cross multiply. I think you should be able to get the answer. But anyway, I think I can simplify 2 times, 3 times, this goes 5 times, so x becomes 15. So if you have to find out this side will be 15 centimeter. Alright? Otherwise, if you were going to do a corollary, you could have taken 4 divided by 14 is equal to 6 divided by, maybe the whole thing could have been y. After you calculate y, if you remove 6 from that, you would have got 15 meters. Alright? That's also another way in which you can do it. It's your choice entirely, depending on what you think is comfortable during your practice or exams. Alright, now comes the proof of how basic proportionality theorem works. Most of you may know some of it, but if you're doing this for the very first time, you do it slowly, pause the video wherever you think it's necessary, and then take it forward. Which is going to be a standard question on your paper. So I'm going to start with proofs of, it's also called Thales theorem, that's the spelling, but all you kids would use the word BPT, short form for basic proportionality theorem. The first thing is the statement. All of us know that the first major thing that goes into a theorem is the statement, and please by heart the statement, because in the exam they will ask you to state and prove it. Okay? The statement is simple. When a line from any two sides of a triangle is drawn parallel to the third side, then the two sides get divided in proportion. Which basically tells you that if I have a triangle like this, it's called ABC, draw a line parallel, then automatically this by this becomes equal to this divided by this. Alright? The statement is very important and it has to be very precise. So please don't change too many wordings and make sure the meaning is communicated very clearly. Okay? If you have understood this, we should start with the remaining part of the theorem. Here goes your statement, here goes your diagram. The next obvious thing is, what are we trying to prove? We're trying to prove this by this is equal to this by this. Always remember, when someone asks you to prove basic proportionality theorem, please prove only the basic formula. Do not prove anything else. Which means you have to prove this by this is equal to this by this. Don't do corollary where you're trying to consider the entire side. That becomes a major no during your exam. So to prove AD by DB is equal to AE by BC. Wonderful. Now that we have understood what we have to prove, let's start proving it very quickly. If you have understood everything so far, alright, I'm going to go to another page because we have to start with the proof. But before that, I'll show you how your construction looks. But I'm going to redo the construction on the next page. Just to keep it uniform, I'll change the color and use a different color. What color do we use? Probably use red. Your construction is, I hope all of you are able to see. I'm going to draw DM parallel to AE. So I'm going to write that. Draw DM parallel to AE. Whatever you do on this side, you do the same thing on this side. Let's call that EN. So you're also going to draw EN parallel to AD. Done. Another simple construction. Join DC. If you do it this side, do it this side too. So you're also going to join E. The most wonderful part about BPT is that everything is so symmetric. So you should be able to do it very, very quickly. Alright? I've done the construction for you. I'm going to go into the next slide to start with the proof, where I'm going to redraw this, and we'll probably have a bigger diagram there so that you understand how that works. Alright? If you want to pause for a bit, please pause and write it down. I'm going to go to the next slide and start with your proof. Alright, how does the proof go? Let me revert to my code color. Let's start with proof. Follow one specific order, life will become very easy for you. And for all the years I have been teaching geometry, I always give all my students one advice. Be extremely generous when you're drawing diagrams. Don't try to save space, because bigger is your diagram, the quicker you will be able to analyze it, right? This was one construction we made, this is BM. This was one more construction we made, which was BN. This was one construction we made, this was another construction we made. Alright? Now the pattern is like this. You start with the top triangle first, then you move to the trapezium plane. Okay? Only 2 steps. First focus on this area, then come to the bottom part of the triangle. Okay? How do we start? First what I'm going to do is, since I told you we need to focus on the top part of it first, you will consider this triangle and we will try to find different ways in which we can find the area of the triangle. So what triangle are we referring to? We are looking at area of triangle ADE. Area of triangle AD is half into base into height. Done. Now listen very carefully. In geometry, this height is always the perpendicular height. It cannot be any other height. Okay? Now, if I choose AE to be my base, if I choose AE to be my base, DM becomes my height, right? Because it has to be perpendicular height and the height should be on the base I'm considering. Since AE is my base, DM is my height. Excellent. We're done with one equation. So this is area of triangle ADE. Done. Now, is there any other way in which I can find the area of triangle ADE? I told you this is a very symmetric way of doing it. Again, I'm going to write half base into height. This time I shall take this as my base. So this is half into, I'm going to take AD as my base. This time, since this is the base, this has to be my height, EN. Let's call this equation 2. What's wonderful about this is, if you notice, both are giving me the area of the same triangle. The only thing I did was I changed the base and the height, but eventually it gave me the same triangle. So since both of them are equal to each other, what I'm going to do is I'm just going to equate both. I'm going to say from 1 and 2, since this one and this one, it gives me the same area. So let's start working on it. So I'm going to get half AE into DM is equal to half AD into EM. Cancel off the half. And you call it AE into DM is equal to AD into EM. Just bring the AD down, so I have AE by AD is equal to EN by DM. Call this equation, I'm done with 1, I'm done with 2, let's call this equation 3. Okay, I hope you're clear with this. We have only focused on the top part of the triangle. I have not done anything apart from that. Okay, pause the video, quickly make a note of what you're supposed to so that we can quickly move ahead and complete the theorem. Once you've done this, I'm going to minimize this so that I can start with the figure, the bottom part of the triangle. Alright? Perfect. Let's start minimizing this and we shall go ahead and work on it. I hope all of you are safe. Bangalore is experiencing floods. I hope all of you are doing safe. Luckily, the area I live in is as good as dry. It's been raining quite a bit, but it's good weather. But let's also pray for all of them who have been experiencing floods. Let's hope that they get back to their normal routine as quickly as possible. Alright, let's go ahead now. Now that this part is done, let's focus on this part. Now here, if you notice, I have two triangles. This is one triangle and this is the other triangle. Okay. Now what I'm going to do is I'm going to find area of, let's start with this triangle. This is triangle DEB, which is again half base into height. Now please be very careful here. When you're finding the area of this triangle, this is an obtuse angle triangle because this is an obtuse angle that you see here. So if I take this as the base, We all know that for an obtuse angle triangle, the height is always an exterior height, which means it is outside the triangle. So if I take this as the base of the triangle, this continues to be the height. I hope all of you are able to follow this. For this triangle, if I take this as the base, this is the height. Alright? So to consider it like this. I hope you are able to figure it out. This is my base, this is my base, this is my triangle, this is my base, this is my height. So I'm going to consider my base to be dB and height to be En. Let's call this equation 4. Similarly, let's take another triangle, DEC is again half base into height, which is half. This time I will take this as the base and this becomes the height. I don't know if you're able to visualize it. I'll just color it for you so that you can differentiate between both the triangles. The one that looks denser is the second triangle I'm considering. This one. Right, this is the second triangle. So this is my base and this is my height. So I'm going to consider EC as my base. This time DM becomes the external height. Call this equation 5. The most interesting thing now is, I don't know if you guys remember this, but if you notice these two triangles, which is DEB and DEC, lie on the same base. And they also lie between the same two parallel lines. Because if you notice, their vertices meet here. The theorem says, if there are two triangles that have the same base, see they're lying on the same base, and if they also lie between the same two parallel lines, then they should have equal area. Which means the area of these two triangles should now become equal to each other. So the area of DEB and DEC should be equal to each other, and I'm going to say as triangle DEB and triangle DEC lie on the same base and between the same parallels, they must have equal area. And since they should have equal area, let's see what happens now, which means area of this should become equal to area of this, which means half dB into En should be equal to half EC into dm. Let's start working on that. To do that, I hope all of you have made a note of it, because I'll have to start minimizing this as well. And remember, this last statement that we all wrote is extremely important, because that forms one major part of your proof, because without that you can't really do much. Okay, everything is right there, minimized form. If you want to go back and see the larger font, you could just go back a little on my video. Okay, having said this, we just learned that the areas are going to be the same. So this implies area of triangle DEB becomes equal to area of triangle DEC. So I have half, this is BB into En equal to half, DEC is EC into DM, half we cancel off, so I get DB into En is equal to EC into DM. Now if you look at the third equation, I have an expression for En by dm. So I'm going to try and get En by dm from the second expression as well. So if I bring dm down, I get En by dm is equal to EC by dB. And I'm going to call this as my last equation, which is equation 6. Now if you compare the third equation and the sixth equation, I get something like this. Now I don't need the diagram anymore, so I'm just going to quickly erase it so that we can finish doing the last part of the proof here. My third equation says AE by AD is equal to En by dm. This was my third equation. My sixth equation says En by dm is equal to EC by dB. Look at how beautiful these two expressions are. This is equal to En by dm, This is also equal to En by Dm, which means these two should be equal to each other. So I get AE by AD is equal to EC by BB. Alright, now just cross multiply, bring EC down, bring AD on top, so I get AD by DB. I'm pushing this on top and I'm bringing this down. So just interchange these two positions. AD by DB becomes equal to AE by EC. And this is your proof for basic proportionality theorem. Ideally, just to summarize, take the top triangle, find area in two ways, using two different bases at two different heights. Then come to the bottom part of the triangle. You have two triangles that lie on the same base and between same parallels. So they'll have equal area. But how do you find the area of those two triangles? You consider bases and external heights because they are obtuse angle triangles. After that, you equate them, try to bring both of them to the same ratio, then equate the ratios, you're done. I think just practicing it a couple of times should ideally help you. It's a very simple one. And with this, I will close this video, which has just the properties and your basic proportionality theorem in it. In the next video that's going to come, I will be doing a lot of problems on basic proportionality theorem, and there will be a third video where we'll be talking about similarity of triangles. I hope you enjoyed this video, and until we meet again, have a good day. Bye bye.